Hi everyone, today we're going to have a look at some graph shapes that you need to recognise, especially if you're doing higher tier. Okay, so if you look at my little yellow box, we're going to cover what a linear graph looks like. Okay, and it says in my little yellow box that in a linear graph the highest power in the equation is x. Okay, we're then going to look at quadratic graphs. So in a quadratic graph the highest power is x squared. We can have x squareds but no higher. Okay, in a cubic graph, okay, we've got the highest power is x cubed. So we've got some x cubed, but no higher. So linear graph, we can have some x's, but nothing higher. Quadratic graph, we can have some x squared, but nothing higher. And a cubic graph, we can have some x cubed, but nothing higher. Okay, so if we have a look at the top, we're going to equation up here that says y equals ax cubed, plus bx squared plus mx plus c. And I should say that I'm using Desmos, okay, the online graphing software, which is superb, so I'm on Desmos. Right, so, okay, don't be scared by this equation, right? It basically says that we're going to plot a graph of y, and y is going to be some number of x cubes plus some number of x squareds plus some number of x's plus some just number. All right, and these a, b, m, and c numbers are just coefficients. Okay, they tell us how many x cubes, how many x squareds, how many x's, and just a single number left at the end. All right, so we can vary those. I've got 4 sliders below. Okay, I can use this one to change my a value. I can use this one to change my b value. I can use this one to change my m value. And I can use the bottom one to change my c value. And you might be wondering why I've called the first one a, b, and then I've got m and c. Well, if you're familiar with y equals mx plus c, hopefully you'll see why in a minute. Right, so let's have a look at my bottom slider. My bottom slider gives c up here some sort of value. So if I leave a as 0, we have no x cubes. If I leave b as 0, we have no x squareds. If I have m as 0, we have no x's. But if I make c 1, we've now got y equals 1. Okay, because this c value here is now 1. So our equation, even though this stuff is here, is no x cubed, no x squares, no x's. You might as well pretend that's not there. We've got y equals 1. And what does y equals 1 look like? Well, it's a very boring horizontal line, and it cuts the y-axis. It intercepts the y-axis at y is 1. Okay, what if we make c 2? Well, our equation now becomes y equals 2. And that's just the line where y is always 2. It's a horizontal line with a y-intercept of 2. And we can keep going. Y equals 3, y equals 4, y equals 5, y equals 6, y equals 7, y equals 8. Okay, and if we make the c value negative, we make it minus 2. Well, if we have c equals minus 2, our horizontal line drops below our x-axis. Okay, and y is now always minus 2. We get a horizontal line with an intercept of minus 2. Y equals minus 6 will look like that line. Okay, so that's the dullest line we can have. Let's set c back to 0. Right, what we'll now look at is our first equation type, a linear graph. So a linear graph can have some x's in it, but no higher. So which coefficient changes my x's? It's the m value. So we're going to leave everything else at 0, and we'll set m as 1. So this would be the equation of the line y equals, none of those, 1x, and none of those. So this is the line y equals 1x, or y equals x. So what does our graph look like? Well, y equals x. Okay, so if x is 1, y should be 1. And if x is 2, y should be 2. And if x is 5, y should be 5. So we could plot all those pairs of coordinates, and you should see that we start getting a straight diagonal line. Okay, what if x is negative 3? Well, when x is negative 3, surprise, surprise, y is negative 3. Alright, so we get an equation y equals 1 gives us this diagonal line. Right, what's the gradient of this line? Well, hopefully you're thinking, well, the gradient's 1. When we go across 1, y goes up by 1. Doesn't matter where we start on our line, if x goes across by 1, y goes up by 1. It tells us the steepness of this line. So in our equation, when we have y equals mx plus c, remember that m tells us the gradient. So if we make m2, what's going to happen to our line? Well, hopefully you're going to predict that that line gets a bit steeper. Now our gradient's 2. when x goes across or up by 1, y now jumps up 2 every time. Every time we go across 1x, we go up 2. The line's twice as steep. What if we make m 5? That will be the equation y equals 5x. Well, this time, when x goes up by 1, y goes up a massive 5. We've got a really steep line. This gradient's 5. Okay, we get the equation y equals 5x. Okay, we'll do 10. Y equals 10x. It's now really steep. When x goes up by 1, y's gone up 10. Okay, negative gradient. What does it look like? If we make y equal to minus 5x, well, this time, when x goes up by 1, our y value decreases by 5. So this is a negative gradient. Okay, we've got a slope that goes from top left to bottom right. Okay, a negative gradient. Let's make m equals minus 8. We get an even steeper negative gradient. When x goes up by 1, this time our y value drops by 8. Okay, so when x increases by 1, y is decreasing by 8. Negative 8 gradient. Y equals minus 8. So hopefully those sorts of graphs will be familiar to you. Now if I just whiz my slider around, you should spot that at the moment my y-intercept is always 0. All of those lines cut the y-axis at 0. So what do I do to my y equals x line to change the y-intercept? Well, this is where our c value comes in. If we increase our c value, let's say to 2, our equation, we've got 1 as m, we've got 2 as c. Our equation becomes y equals 1x, y equals x, plus 2. Our c value is now 2. And what do we notice? We notice that our y-intercept is now 2. So it looks like the c value here is our y-intercept. Let's check it out. Okay, let's leave the gradient the same steepness, but let's make our y-intercept negative 6. Okay, so we see straight away that our line changes where it cuts the y-axis. It now cuts at negative 6, but the steepness, the slope, the gradient doesn't change. Okay, all of those lines are parallel. Okay, so the only thing that's changing this time is where it cuts the y-axis. Right, let's set it back to 0, so the intercept is at 0. Set m back to 0. Okay, so this time we've got nothing at all. We've got y equals nothing, 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 nothing. Right, let's leave m at 0 this time, and let's look at our next set of graphs, the quadratic graphs. So quadratic graphs, the highest power we can have is x squareds. So that's our b coefficient. We're going to leave no x cubed, a is 0. For a start, we'll have no x's. We'll make m 0 and no added on numbers at the end. So c will be 0. Okay, but let's make b 1. So this will be the graph of y equals 1x squared, or y equals x squared. And what do we get? We get a shape called a parabola. This is brilliant, this shape. This is the shape that if you throw a ball in the air, okay, the ball will follow this pattern. Okay, lots and lots of applications in physics. Okay, so this is y equals x squared. Okay, now I said if you throw a ball in the air, you might be thinking, hang on a minute, amps, it doesn't do that. Okay, that's going down and then it's going up. Right, let's make b minus 1. This is y equals negative x squared. Y equals minus x squared. Right, that looks more like the path of a ball, the trajectory of a ball. We throw it up. It'll follow that path. Alright, so if we have a quick slidey slide and change the b values, if I make y equals 5x squared, what do we get? We get the same sort of shape, but it's a bit narrower, it's a bit steeper. If we make b minus 8, we get a really kind of steeper curve, if you like, tighter. Two lines are closer together, but again, it swaps position. It's reflected around the x-axis. So any positive value of x squared gives us a smiley, and any negative value of x squared gives us a sad face. So this is something you need to remember with quadratics. Okay, and just remind ourselves, quadratic, we've got some x squareds in there, nothing higher. If we've got positive x squareds, think positive, we get a smiley. If we've got negative x squareds, we get a sad face. So if you want to sketch one of these, look at the coefficient in front of the x squared. If it's positive, smiley. If it's negative, not so cheerful. All right. Okay. What happens if we change the other values as well? Let's make y equals 4x squared. Okay, we could then start adding or subtracting some x's. And you'll see it changes the position of the quadratic graph, but it's still the same shape. Okay, what if we add some constant numbers at the end as well? We add our c value. Ooh, it just shifted up and down along the y-axis. All right, so nothing changes the fact that we've still got smiley. Oh, sad. Okay, it doesn't matter what we do with these. Okay, that basic shape stays the same. Okay, so that's called a parabola. It's the curve we'll get from a quadratic graph. Right, set everything back to 0. Okay, let's look at the last one. Cubic. What's a cubic going to look like? This time we can have the highest power as x cubed. So this time a needs to be something other than 0. Okay, if we want some x cubed, we better make a, let's say, 1. Okay, so if we leave everything else set as 0, this graph is y equals 1 x cubed, y equals x cubed. And what do we get here? Well, we get something with a bit of a kink in the middle. All right, we get some sort of line, this one that starts bottom left, kinks a bit, and then goes top right. Okay, what happens if we increase the number of x cubes? What about y equals x cubed? Sorry, what if we get y equals 2x cubed? What if we try y equals 3x cubed, 4x cubed? Well, you can see that the y value is increasing more. We get a steeper line, but the shape's basically the same. We've got some sort of kink in the middle and some sort of bottom left to top right. What if we try some negative x cubes? These were positive. What about some negative x cubes? Oh, it's reflected in the y-axis. So you get the same basic shape, but this time it goes top left to bottom right. Okay. What if we play with adding some of the other values in as well? So what if we've got some x cubed and we add some x squared? Ooh, we get a big kink. We go that way. Ooh, we get a big kink. Okay, what if we change the m value? So we add some x's as well. Right, it changes, okay, how, I guess how tight that little kink is. It might stretch it out, or it might be really, really pronounced. And if we change the c value, oh, just like before, it's adding our graph up along the y-axis, or shifting that shape down along the y-axis. Okay, so cubics, negative, top left to bottom right, positive, bottom left to top right. Everything else is just changing how pronounced that kink is and where exactly the pattern is on our set of axes. So you can imagine like this like a rope. A cubic graph is like a rope. Okay, and that rope can be pretty stretched out, but there's still, if you look carefully, a bit of a kink in the middle. It'll never go straight. Okay, it looks like it nearly is there, but it's never going to go straight. Or it could be a big wiggle in the middle. There's either a big wiggle or an almost stretched out one. Okay, you can even get that bit in the middle flat, okay, if we choose the right values. But there's still some sort of kink. Right, so we've got cubics. It's the wiggly one with a kink. We've got quadratics. It's the one we've got smiley, not so cheerful. We've got linear graphs, ones with just powers of x and no higher. Easy. Straight lines, y equals mx plus c, where m is the gradient and c is the y-intercept. And most boring of all, y equals 6. Y equals minus 2. Not very interesting. So, key shapes for you to learn. If it's y equals mx plus c, if it's just got some x's in, it's going to be a straight line. If it's got some x's in, plus a value, minus a value, the y-intercept will change. If we've got x squareds, smiley if they're positive, unhappy if they're negative. So if the coefficient of x squared is negative, we'll get a sad one. And the cubics, they're a bit kinky. Okay, they got the kink in the middle. They might be stretched out. It might be really pronounced. Okay, but they got a kink in the middle. And if the coefficients of our cubic graph, or the coefficient is positive, we've got y equals, let's say, 3x cubed, the graph will go from bottom left to top right. That's a bit like with our linear graph. Imagine a positive gradient. With a negative x cubed, okay, it will go from top left to bottom right. Think of the linear graph again. That will be like a negative gradient. So they just match up with the linear graphs. They're your key shapes to remember. Okay, we'll do some practice questions and see how good you are.